Welcome to the 99th video in our series about Unix tools. In this video, we'll take a quick look at compiling a Cobol program. For this to work, your system administrator needs to install the GNU Cobol compiler for you. And I need to get this right. Okay. Like Fortran and Pascal, Cobol is an old language. It is designed for writing reports, working with databases, but has been used for many other tasks at one time or another. Cobol has the same advantages that Fortran does: 70 years of compiler development and sample code. The optimizers in Fortran and Cobol are truly amazing. Cobol has a bad reputation because the syntax is very verbose. Also, most Cobol source code is like most Fortran source code. It was designed to be used on punch cards, so it has a very strict column layout and short lines. But whether you love it or hate it, you need to know how to compile and run Cobol code. Many government institutions, many banks, they still use a lot of Cobol. And because most of the original generation of Cobol programmers are in their 70s, people like IBM are desperate to find new Cobol programmers. And if you're willing to accept the verbosity, which won't be too bad if you're using a Unix system and you can use VIM, you can make some real money as a Cobol programmer. So the GNU compiler for this has an executable name called cobx. Let's learn how to use it. I have a sample program. This is a Hello World program. You'll notice, like Fortran, it has rules about how far, what column the actual code starts in. These columns on the left, like Fortran, are reserved for line numbers and continuation bytes and things like that. But one look at this and you can see, wow, there's a lot of boilerplate or a lot of setup code. But here's our variable declaration for the variable I, and it's numeric with 2 places. Remember that Cobol can do decimal math, so the math in this is quite different. It's why banks love it. Decimal math will give you the same rounding that you would do by hand, so it's good for working with money. Whereas floating point math is loved by scientists, but it's awful for working with money because it'll get round off errors. Okay, enough of the hard sell. Here's an assignment statement, I equal 10, and here's our print. So, how do we compile this thing? If it's just one file, it's pretty easy. You can do a cobx, and then you do a -x because you want an executable. Give the source file name and specify your output file name. And cobc, excuse me. Alright. Anyway, cobc. You got to use -x with cobc. When we run it, we get the output that we got in our other simple Hello World programs. And so that seems pretty good. One of the things that Cobol can do is separate compilation. We've noticed some of the newer languages make that really difficult. Rust just doesn't do it. But we can do it. And I have a nice 2-file sample up here, demo external and demo sub. So let's take a look at those and see what we can learn. Demo external. This is our main. This is the program that has main. And notice they've put a little main indicator here. And what's different about the variable declaration is that it's marked external, which would be called a common block in some languages like Fortran, extern in C. But what that says is that those variables are global for the entire executable. Okay? And then we do an assignment. So they move all X to arg, and then they call demo sub, a subroutine. They don't have any parameters. And finally, they do a display of this arg, which got modified as a side effect of demo sub, which in this case is a procedure. And then they've used go back instead of stop program, but we're not going to worry about that right now. This is the main. And then if we look at demo sub, this is the subroutine. Again, it has an identical declaration of the variable, which makes sense because it's the same storage location. It's external. And then what they do is they move stars. So the main program puts a bunch of X's into arg. And then it calls the subroutine, which puts can I mark one byte? I can. It moves asterisks into arg so that you can see it did something. And then the go back, that's like a return, and it will return to the main. Okay, so there's the code. How do we compile this stuff? In C and in Fortran, we had compile into objects, and we had link all the objects into an executable. Well, guess what? Cobol has 3 possibilities. Compile into an object and it doesn't have main. Compile into an object and it does have main. And link all the objects. So let's do it. First, we'll compile a source file that does not have the main, which for us was demo sub. And that looks just like C or Fortran. No big deal. We have to add an -X for the demo external to indicate that this is the one and only one that has the main inside of it. But this is still just a compile. And then finally, we do the link, which we have to specify a -X and no -C. And that tells us we want an executable. And then we can list our object files. And we can put it where we want to put it. Traditionally, somebody would choose this. And when we run it, you can see you got your 10 asterisks. So that's separate compilation. You can see that this would work well with a make file, but it'd be a little tricky because you need to have a special rule for this one that we don't need in Fortran and C. Are there command line options available for this Cob C compiler? Or is it like Go and you just use the defaults? Cobol's old. So of course they've got a million options. I won't keep going, but you get the idea. There are many options. And I've taken a little time to figure out some of the most common ones that you might use. if you were wanting to say, I need it to be Cobol 85, because there are many different Cobol standards. Cobol 85 is pretty common, and a lot of old code is Cobol 85. Fixed. Fixed says we're doing it like the punch cards because most Cobol source code is in that format, just like most Fortran code is. Does Fortran have a free format mode? Yes, and so does Cobol, but I haven't seen much source code using the free format. Turn on all the warnings, which can help you find silly style and maybe semantic problems with your code. So let's try this one. And this is an all-in-one. This is a compile and link a single source file to hello.com. So if we go for that, the good news is we have no warnings. I forgot to say this is optimized to the maximum available. And there it is. You might want to know how big is that file. Not bad. You know, that's a lot smaller than some of the other executables we've seen. Can we strip it? Clearly it made no difference at all. So it's already as small as it's going to ever be. And you can see, wow, they pull in all kinds of stuff. You know, they've got compression, they've got the math library, more compression, incurses, it's got the terminal info library, it's got international components for Unicode library. Part of it must be written in standard C++, right? It's got XML support, GNU multiprocessor, and all that stuff is necessary because they have one library that's used in every Cobol program, and so they have to include everything they're going to need. And because Cobol has so much built into it, there's a lot of libraries linked in. But that's it. That's all it takes to compile your Cobol. And because Cobol has good support for separate compilation, even though the syntax looks a little weird, you could use make with this if you wanted to, or some other build system. Okay. That marks the end of our break from Git. Our next video is going to return to the Git version control system, and I hope you'll come back for it. Until then, thank you for listening.